Alright, hello everyone, this is Mr. Crozier. I'm going to give you some help on the Chapter 4 review problems 11 through 16. I'm not going to work them out for you completely, but I will give you some help. Number one, it's just a straightforward derivative. However, you have a chain rule going on here, actually twice. You have this 3x that's inside of this sign, and then you have this whole thing that's inside of the square root. And again, my first step, always on these problems, is to take this and rewrite it as a power. It's much easier to deal with it as a power. So we have a 3x inside of a sign that's all inside of a power. Power rule, sign rule, and then just the coefficient right there. Alright, number 12, find the slope. Well, we did one of these problems yesterday, and same exact thing. See if you can get the right decimal here. And on these problems, what happens is you get to a point where you have one fractions equal to another fraction. And just go ahead and cross multiply them. It's going to be the best way to solve for what you're looking for. I wouldn't distribute too much when you get into the work unless you have to, but you should be able to come up with an answer for x for the slope. Finding the derivative here. Well, it's kind of a tough derivative. Again, I do a couple things. Number one, I'd pull this constant out to the front, so we have 100 of this derivative, and if we're going to take the derivative of that, again, I would write it as a power. So you could use a quotient rule here. Might be easier, it might be really messy. I like to pull the constants out and then do this derivative. You can find the derivative there. You can check it on Symbolab. And then down here it says use the calculator to find the maximum value of the derivative over this interval. From 0 to 10 is all we're looking for. And what we're doing here is just looking for, this z stands for integers. So all you need to do is make that derivative table of y prime in 0, 1, 2, 3, 4, all the way down to 10, and just integers. So you don't have to worry about 1.1 or 1.2. And when is this the highest over here? So you're looking for that. And again, when you're typing it in here, a couple things you can do. You can type this derivative directly into here, but that's going to be kind of messy. Or if you put any function in here, let's just do 2x squared plus 7. And then if you want to go down and do the derivative here, you can just do math, type, and do the derivative, and right here we're going to put y1, and we get that by going alpha calculator, and I can do y1, and that's going to do the derivative automatically for me. It's doing the derivative of this first function here. So if I jump straight to my table, I'll have my two values. Alright, number 14, find the derivative here. Nothing fancy. Plug in a 3. It is a rather large derivative, and the reason why it's rather large is because this is an exponential equation. An exponential equation shoots straight up. So that derivative at any point there is going to be really high, and it's extremely high in this case. Find the tangent here. You got to use some implicit differentiation, which means it's going to be 2x plus 2y, and don't forget the dy dx, minus 2 plus 4, don't forget the dy dx, equals 0. Solve it for dy dx, plug in your point, find the tangent means y equals mx plus b, take it all the way to the equation. And the last one, well, this derivative is not too hard, right? The derivative of tangent inverse is just 1 over 1 plus x squared. But you have a chain rule involved. It's not too hard. When you do plug this in, the algebra is tricky on this one. You're going to have complex fractions that you have to simplify. These are just random numbers here, but you'd have to simplify a complex fraction like that. And you're also going to have rational numbers that need to be, or you're going to have rational numbers in the denominator which need to be rationalized. And you might also have, could have irrational numbers down here in the denominator in a complex fraction. So the Calculus on this one's not too bad. The algebra on this one is kind of tough. So double check it. You can check it on Symbol Lab, you can check it on Desmos, but that should get you started on these problems.